what is the need of data structure. Let's first understand the need of data structure. As applications grow in complexity and the volume of data continues to surge daily, challenges may arise in tasks such as data searching, processing speed, and handling multiple requests. Data structures offer diverse techniques for efficiently organizing, managing, and storing data. They facilitate seamless traversal of data items, providing benefits such as efficiency, reusability, and abstraction. It is quite natural to get a question: why should we learn data structures? Data structures and algorithms stand as a pivotal element in the world of computer science. While data structures provide the means to organize and store the data, algorithms empower us to process that data with purpose. Acquiring proficiency in data structure and algorithms is instrumental in elevating our programming skills. This knowledge enables us to craft code that is not only more effective and reliable, but also empower us to solve problems swiftly and efficiently. Some of the objectives of data structures are accuracy. Data structures are crafted to function accurately across the spectrum of inputs relevant to the specific domain. In essence, ensuring correctness is the foremost goal of data structures, and it is conditional upon the challenges that the data structures aims to address. Optimization. Data structures must also prioritize efficiency. They should swiftly handle data processing without excessive utilization of computer resources, such as memory space. In real time scenarios, the efficiency of data structures plays a pivotal role in determining the outcome of a process, be it success or failure. Key features of data structures are robustness. In general, the goal of all computer programmers is to create a software that produces accurate results for any conceivable input while executing efficiently across diverse hardware platforms. Such robust software should effectively handle both valid and invalid inputs. Adaptability. The development of software applications like web browsers, word processors, and internet search engines involves expansive software systems that must demonstrate correct and efficient performance over extended periods. Furthermore, software undergoes evolution due to emerging technologies and ever changing market conditions. Reusability. The attributes of reusability and adaptability are inherently interconnected. Building software demands considerable resources, making it costly endeavor. However, when software is developed with a focus on reusability and adaptability, it can be seamlessly applied in numerous future applications. By employing robust data structures, it becomes feasible to construct reusable software, thereby achieving cost effectiveness and time saving.